Alright, all geometry students, this is section 2.7, part 2 of Prove Angle Pair Relationships. So I'm going to flip through again until we get to where we ended last time. Okay, so here we are. We're going to identify the pairs of congruent angles in the figures below. Explain your reasoning. So, in this first one, we can identify wherever we see a right angle symbol, that those angles are congruent. So we can say, let's identify them as angle PVQ undo that. It's congruent to angle UVQ, and that is congruent to QRS. And all of those are congruent because of the right angle congruence theorem. Okay. The next one, very similar to what we had in the last video, is we have angle 1 and 2 are complementary, 2 and 3 are complementary, and 2 and 4 are supplementary. I'm going to mark this one out because that's just a bit too much information. So looking at angle 1 and 2 are complementary and 2 and 3 are complementary, we can see that if they are complementary, then we should know that these two angles right here are congruent by the congruent complements theorem. Okay. Next slide. Okay. So on this one it says find the values of x and y using information in the diagrams. So let's just start on this. If we know vertical angles are congruent, we can find out if we set these two angles equal to each other, we will find x. Same goes for y. If we set these two angles equal to each other, we will find what y is equal to. So I'm going to say 13x plus 9 is equal to 15x minus 1. And solving for x, we get, I'm going to say 10 equals 2x. So x equals 5. Now, let's do the same for y. We can say 4y plus 2 is equal to 2 times 3y minus 25. Now, using your distributive property, we get 4y plus 2 equals 6y minus 50. Now, using your subtractive properties and addition properties, we are going to get 52 is equal to 2y. And then divide both sides by 2, we get 26. And there we go. We solved for x and y. Now, let's do the same thing, sort of the same thing on the other side, except using a different theorem. We used, for number 3, that vertical angles are congruent. On number 4, we're going to use the fact that these two angles are linear pairs, meaning they add up to 180 degrees. So, to figure out x here, we're going to say 4x plus 10 plus the 13x equals 180 degrees. And that will get us our value for x. So combining like terms, we get 17x plus 10 equals 180. And then 17x equals 170. So x equals 10. Now do the same thing for y. So y, these two things right here are supplementary angles. So add them up together and set them equal to 180. 2y plus 25. Need more room on this one. Plus 2y minus 30 equals 180. Now again, use your distributive property. We get 2y plus 50. Then write down everything else. Combine your like terms. You get 4y plus 20 equals 180. Subtract the 20 from both sides. We get this, and divide both sides by 4. We get y equals 40. And there you have it. We solved for x and y's in both of our numbers here, 3 and 4. Now let's do some proofs. We are going to prove the vertical angle congruence theorem. Okay? It's actually only 4 steps long, so not too bad. And we are going to be actually using a couple other theorems to help us in proving the vertical angle congruence theorem. So given, I'm going to write that first. 5 and 7 are vertical angles. Okay. Alright, so part 2, we can actually state that angle 5 and angle 6 are linear pairs, and also angle 6 and 7 are linear pairs. And this is going to help us in figuring out that vertical angles are congruent. See, angle 6 and angle 7 are linear pairs. So, but this right here, the second step, used the definition of linear pair. Alright, step 3. Okay, if two angles are linear pairs, then those two angles are supplementary. Okay, and that is by the linear pair postulate that we had just looked at in the previous section. So angle 5 and angle 6 are supplementary. And then angle 6 and angle 7 are supplementary. Some of you might know where I'm going with this. So I stated that this is the linear pair postulate. Alright, so remembering the congruent supplements theorem, that if we have two angles are said to be supplement and another two angles to be said that they are supplement, and two of those angles actually match each other, then the other two angles, so 5 and 7, are congruent to each other. So angle 5 is congruent to angle 7. Congruent supplements theorem. Okay, and that's where we are. That's how we get the vertical angle congruence theorem. Okay, let's do another proof. Okay, it says to write a 2-column proof given angle S is a right angle and the measurement of angle RTS is equal to 40 and the measurement of RTU is equal to 50. And we're going to prove that angle S is congruent to angle STU. Okay, so step 1, state the given information. And let's see, measurement of RTS equals 40. RTU equals 50. Alright, step 2. Now, if we know that angle of 40 and 50, then we can say, let's add them together. Measurement of RTS plus the measurement of RTU is equal to the measurement of angle STU. And that is just using the angle addition postulate. Okay, now step number 3, I am going to use substitution because we have the measurement of angle RST, that's 40, and measurement of RTU, that's 50. Substitute both of these in. We get 40 and 50. And then combine these terms together, 40 and 50. So here I just use substitution. Step 4, I'm combining like terms. So this is equal to 90 degrees. And raise this up. Step 5. We're going to say that angle STU is a right angle. By definition of right angle. Because by definition of right angle, angles are exactly 90 degrees. Let's see, right angle. Now, step 6 here, we can say angle S is congruent to angle STU because of the right angle congruence theorem, which states all right angles are congruent. And we are done with that proof. We just stated this one right here as our last statement and gave a reason. So we are done. Alright, I have one last proof for you guys and we'll be done for the night. Alright, so this is our last one and it's actually kind of a fun one to me, it is. We're going to be using this given information up here, that angle 1 and angle 4 are complementary and angle 4 and 5 are complementary. Then we're going to be using these two right here, that angle 2 are supplementary and angle 5 and angle 6 are supplementary. Then finally we're going to use this fact that the measurement of angle 1 is equal to 52 to show that the measurement of angle 6 is 128 degrees. So this is kind of long, but not terribly long. We can get through it. So let's start out with part of our given information, that angle 1 and angle 4 are complementary. And angle 4 and 5 are complementary. So that's just our given. And from here, if you remember the congruent complements theorem, we can say that angle 1 and 5 are congruent. Okay, so that used the congruent complements theorem. Alright, so step 3, we are going to say, let's use this given information, that angle 1 and angle 2 are supplementary and angle 5 and angle 6 are supplementary. That's just the rest of our given information. Whoops. Now, step 4 here, what I'm going to do is do some substitution. You can see that angle 1 is congruent to angle 5. Well, I am going to substitute angle 1 in for here and say angle 1 and angle 6 are supplementary. Okay. So that's the substitution property. Okay. Now, for step 5, I can say if angle 1 and 6 are supplementary, then the measurement of angle 1 plus the measurement of angle 6 equals 180 degrees. And that is definition of supplementary. Supplementary angles. Now, on this one, what I'm going to say is, let's substitute in what we know measurement of angle 1 to be. Well, I guess we need to state that in our given information somewhere. Let's say up here that we already stated measurement of angle 1 is equal to 52 degrees. There, that way we don't have to state it over again. So let's substitute 52 degrees in for angle 1. And then that was just the substitution property. Now, subtract the 52 from both sides, and we get measurement of angle 6 is equal to 128 degrees. And that was by using the subtraction property. Okay, and we are done. We just proved that the measurement of angle 6 is equal to 128. So, there we have it. All done. So, that was the last proof I have for you as an example. In this section, we'll do plenty more in our homework problems. So I will see you in class and I'll help you then. Goodbye, everybody.